In the last video, I said that spring energy was another common form of energy. But how is it that common? I mean, we don't see things with springs all over the place. So why do we really care about spring energy? Well, let's look at what the potential, the graph of that potential energy looks like. So if we graph the potential as a function of x, remember that the spring energy is 1/2 spring constant k x squared. So in other words, we have something that looks like a parabola, because this is a function of x squared. So now let's look at a case, something that is very common. So let's say we have some kind of molecule where we have, some large atom bonded to some much smaller atom. Okay? So the potential energy in a case like this would look something like this. Okay? So in other words, x, we're calling this distance between the centers of mass of the two objects. So how's this related to a spring energy? Well, notice in this region here, this is very roughly just a parabola. So in other words, in this region, this system is going to behave exactly like a spring would. So this is actually telling us that this atom is going to vibrate slightly, and also this bigger one is also going to have a small vibration to it. So this is telling us how molecules vibrate and how they're bonded together. And so it turns out that this spring energy is, it approximates a lot of different systems. So it turns out that this is actually one of the most useful energies. In fact, another example would be, let's say we have, like a buoy that's floating in the water, and we push it down, some distance. Well, we know that it's going to start to bob up and down, and its potential is going to behave exactly like this. It's going to look just like it's just like it's a spring. But it's even more fundamental than that. If we look at a solid, we can approximate a solid as just a collection of atoms that are all tied together by springs. So we talk about the energy between all of the different atoms in the solid as being related by these different spring potentials. It turns out that's a very good approximation. So even solids behave like springs. But it's even more fundamental than that. It turns out that if we look at the fundamental particles that make up the universe to a very good approximation, we can treat the potential between them acting just like springs. So in other words, quantum fields, okay, so the very forces that tie everything together in the universe are approximated by springs, which is basically saying that everything, to a good approximation, behaves like a spring in some given regime, right? So like in this atomic case, if we got over here, we see that it's not really behaving like a spring anymore. It's only in this region. Well, just about everything has some region where at some point it's kind of behaving like a spring. And so, while you might not deal with springs a lot in everyday life, for those of you who are biology majors or chemistry majors, this spring force, this spring potential is actually very useful. So knowing how to deal with this spring energy is going to be very useful for just about all of you.